For topic 4, we're going to look at building half angle formulas for sine, cosine, and tangent. And earlier in this worksheet, we looked at manipulating double angle formulas to find values for sine squared theta, cosine squared theta, and tangent squared theta. And I told you, don't forget those. They're coming back. Okay? So they're back. All right? So I have them written here for you. We know that sine squared theta equals 1 minus cosine of 2 theta, all divided by 2. Cosine squared theta equals cosine of 2 theta plus 1 all over 2. And then tangent squared theta equals 1 minus cosine of 2 theta all over cosine of 2 theta plus 1. Okay. Now, something that you need to notice is in these formulas, okay, the value of theta right here, right here, right here is half the value of the angle 2 theta. So if I were to take 2 theta and divide it by 2, I would just get plain old theta. So essentially, theta is half the angle that we have in these formulas, okay? So that is not totally an accident, okay? So what we're going to do is we're going to take these values for sine squared theta, cosine squared theta, and tangent squared theta, and we're going to manipulate them to get something called a half angle formula. So again, it's really, really important that you understand theta all by itself is half of 2 theta. Theta all by itself is half of 2 theta. Theta all by itself is half of 2 theta. So what we have here is half of what we have here. What we have here is half of what we have here. What we have here is half of what we have here. Okay, so that's what makes this work, what I'm about to show you. Okay, so for example 7, it says use the above identities where theta is going to be replaced with alpha over 2. So we're going to use alpha over 2 so we don't get totally confused here. So we're going to replace all of our thetas with alpha over 2, okay? So let's do that. Let's start with sine of alpha over 2, okay? So I'm going to take the formula here, sine squared theta equals 1 minus cosine of 2 theta all over 2. And I'm going to replace my thetas with alpha over 2. And that's going to give me some value for alpha over 2. Okay? So I get sine squared. Well, theta we're saying is alpha over 2. And that's going to equal 1 minus cosine of 2 times theta, which is alpha over 2, all over 2. So I get sine squared of alpha over 2 equals 1 minus, well, I have cosine of 2 times alpha over 2. Well, 2 times alpha over 2 is just alpha. So I get 1 minus cosine alpha all over 2. And now it's a little easier to see that half angle idea. So sine squared of alpha over 2, and then we have like the full alpha right here. Okay, so we've got that half angle right here with sine squared. Now we want to solve and just get sine of alpha over 2. That's what we're looking for right here. Okay? Well, in order to undo something that has been squared, we take the square root of both sides. So I would take the square root of both sides, and that would give me sine of alpha over 2 equals plus or minus. Don't forget your plus or minus. And it's going to be plus or minus 1 minus cosine alpha all over 2. And this right here is the half angle formula for alpha over 2, for sine rather. So we're going to get plus or minus the square root of 1 minus cosine alpha all over 2. Now here's the deal. We have that plus or minus. The plus or minus depends on what quadrant alpha over 2 lives in. Recall, sine is positive in quadrants 1 and quadrants 2, and sine is negative in quadrants 3 and quadrants 4. Okay, so when it comes down to determining if we get plus or minus this radical stuff, it all depends on where our angle alpha over 2 lives. Okay, and there's a way we can figure that out. We'll look at that in the next video. Okay, so next up, let's look at sine of alpha over 2. So please remember that we start out with cosine squared theta equals cosine of double theta plus 1 over 2. Okay, and our directions here tell us, let's go ahead and replace that theta with alpha over 2. Okay, so I have cosine squared theta, but theta is really alpha over 2. And that's going to equal cosine of 2 times theta, but theta is alpha over 2. And then plus 1 all over 2. Okay. So we just have to do a little simplifying here. So cosine squared alpha over 2 is just cosine squared alpha over 2. But then for cosine of 2 times alpha over 2, well, 2 times alpha over 2 is just alpha. So I get cosine alpha plus 1 all over 2. And remember, to undo something that has been squared, we just take the square root of each side. So cosine of alpha over 2 finally equals plus or minus the square root of cosine alpha plus 1 all over 2. So I will go ahead and put that up here, plus or minus the square root of cosine alpha plus 1 all over 2. So we have these new half angle formulas to remember. And just remember, the plus or minus, you're either going to get plus this square root or minus this square root. It all depends on where the angle alpha over 2 lives. So again, the plus or minus depends on what quadrant alpha over 2 lives in. And remember, when we're dealing with cosine, cosine is positive in quadrants 1 and 4. Okay, so remember that. And cosine is negative in quadrants 2 and 3. Okay, so you got to remember which quadrant these trig functions are positive versus negative. Okay. Now we're going to do basically the exact same thing, but this time we're dealing with tangent, okay? So we want to know what tangent of alpha over 2 is, so we're going to use this tangent squared formula. So we're just going to remember that tangent squared theta equals 1 minus cosine 2 theta all over cosine of 2 theta plus 1. And then we're going to do what the directions say, and we're going to replace theta with alpha over 2. So we get tangent squared theta, but theta is really alpha over 2. That's going to equal 1 minus cosine of 2 theta, but theta is alpha over 2. That's all over cosine of 2 theta, but remember, theta is alpha over 2. So 2 times alpha over 2 plus 1. We got to do a little simplifying, so let me scroll down a smidgen. So we have tan squared of theta over 2 equals 1 minus cosine. Well, we have cosine of 2 times alpha over 2, but 2 times alpha over 2 is just alpha. So I get 1 minus cosine alpha all over cosine alpha plus 1. Now remember, we want to find out what tangent of alpha over 2 is, not tangent squared. So to undo that tangent squared, we take the square root of both sides. So I get tangent of alpha over 2 equals plus or minus. That plus or minus is so important. And it's going to equal plus or minus the square root of 1 minus cosine alpha all over cosine alpha plus 1. And let me write that up here. And highlight it so you know that it's one of our important identities. And then I'll remind you that the plus or minus depends on the quadrant that alpha over 2 lives in. And it can be a little tiny bit of work to figure it out, but I'll show you a trick to figure it out pretty easily, okay? And I do want you to remember tangent is positive in quadrants 1 and 3, and tangent is negative in quadrants 2 and 4. Okay, so you do need to remember the signs for where sine, cosine, and tangent are positive versus negative. Not the signs, but the quadrants. You need to know the quadrants where each of these trig functions are positive and the quadrants where these 3 trig functions are negative. And that's going to be a big trick to figuring out whether we use the plus or minus these radical expressions. Okay? Now there is another half angle formula for tangent. If I remember correctly, I feel like we proved one of these in a different worksheet maybe, but don't worry too much about this. We're not going to derive it, just know that it exists, okay? All right, so that's it for this video. In the last video for this worksheet, we're going to look at using the double angle and half angle formulas, okay?